All right, day 14. We're going to be looking at page 26 in your book. We're going to look at linear inequalities in one variable. We're going to treat inequalities very similar to our equations. We use inequalities to describe order on a number line in section P.1. For example, if x is to the left of 2 on the number line, or if x is any real number less than 2, we write x is less than 2. The most basic inequality in algebra is a linear inequality. So the only thing that makes this different here than an equation is the fact that it has an inequality sign in it. So a linear inequality in x is one that can be written in the form ax plus b is less than 0, ax plus b is less than or equal to 0, ax plus b is greater than 0, or ax plus b is greater than or equal to 0, where a and b are real numbers and a cannot equal 0. To solve an inequality in x means to find all the values of x for which the inequality is true. A solution of an inequality in x is the value of x for which the inequality is true. The set of all solutions of an inequality is the solution set of an inequality. So when I'm dealing with an inequality, I'm going to see that I solve it very similar to equations, but I'm going to have more than one answer. So let's look at our properties of inequalities on page 27. Let u, v, w, and z be real numbers, variables, or algebraic expressions, and c is a real number. So your transitive property, if u is less than v and v is less than w, then u has to be less than w. Addition property, if u is less than v and u plus w is less than, then u plus w is less than v plus w. If u is less than v and w is less than z, then u plus w has to be less than v plus z. And guys, these just kind of seem like a bunch of words and letters, but once we get into it, you'll see it makes sense. All right, then you have the multiplication. If u is less than v and c is greater than 0, then uc has to be less than uv. And if u is less than v and c is less than 0, then uc has to be greater than vc. The above properties are true if less than is replaced by less than or equal to, and there are similar properties for greater than and greater than or equal to. The set of solutions of a linear inequality is one variable form of interval of real numbers. Just as with linear equations, we solve a linear inequality by transforming it into an equivalent inequality whose solutions are obvious. Two or more inequalities are equivalent if they have the same set of solutions. All right, so let's solve a linear inequality. All right, so I'm looking at 3 times x minus 1 plus 2 is less than or equal to 5x plus 6. All right, let's get rid of our parentheses. Multiply. 3 times x is 3x. 3 times negative 1 is negative 3. Plus 2 is less than or equal to 5x plus 6. All right, so add my like terms. I have negative 1 here. Now I can subtract 3x. I get negative 1 is less than or equal to 2x plus 6. Subtract my 6. Negative 7 is less than or equal to 2x. Divide by 2. And I get negative 3.5 is less than or equal to x. Now, guys, make sure you're very careful about how you're reading this. Negative 3.5 is less than or equal to x. I can rewrite that so that my x is in front. But if I do that, then I have to make sure I switch my inequality signs. So now I can see that x has to be greater than or equal to negative 3.5. So the solution set of the inequality is the set of all real numbers that are greater than or equal to negative 3.5. So here's how I would write this. I'm no longer looking at x as only negative 3.5. X can be anything bigger than negative 3.5. So that means if I were to look at this on a number line, I would see everything bigger than negative 3.5, but guys, it never stops. My numbers never stop, so I could choose 1,567,200, or I could choose 1 trillion, and it would still work. So in order to write this, remember we said brackets include, and since it's greater than or equal to, I'm going to include negative 3.5, and it actually goes to infinity. And then I put a parentheses here because infinity never stops. So it's not stopping at infinity. All right, so this is my solution set for this inequality. This tells me that I start at negative 3.5, and I include that, and I'm going to go all the way up to everything positive, everything bigger than negative 3.5. All right, solving a linear inequality involving fractions. Let's look at that. Once again, I'm going to treat this very similar. So I have x over 3 plus 1/2 is greater than x over 4 plus 1/3. Guys, the only thing different here is I actually have 3 numbers now. So I've got to look at 2, 3, and 4. So 2, 4, 6, 8, 10, 12, 14, 3, 6, 9, 12, 15, 4, 8, 12, 16, 20. Start looking for what they have in common. That all 3 have to have it in common. You're going to see that 12 is the first number that they have in common. So now I've got to come over here and multiply everything times 12. All right, multiplying everything times 12. So when I multiply this, 3 goes into 3 one time, 3 goes into 12 4 times. So I end up with 4x. I end up with 12 over 2, which is the same as 6, is greater than 12x over 4 is the same thing as 3x. And 12 over 3 is the same thing as 4. Okay? Now I can solve it. Subtract my 3x. I get x plus 6 is greater than 4. Subtract my 6. X is greater than negative 2. All right, so once again, I need to list my solution set. Remember, because it's an inequality, it's not just one number. It's many numbers. All right, so if I'm looking at it on a number line, x is greater than, so negative 2. X is greater than, so everything above negative 2. Notice negative 2 is not included because it is not a greater than or equal to sign. So because it's not included, my solution set's going to start with a parentheses. So I'm going to start at negative 2, but negative 2 is not included. And I'm going to go to infinity. So that is my solution. It shows you how to graph it, so make sure you understand how to graph it. Solving a double inequality. What is a double inequality? Is simply where you have more than one inequality part. So here I'm looking at negative 3 is less than 2x plus 5 over 3 is less than or equal to 5. Guys, I have a fraction. The nice thing about it is I only have have one number, so I can multiply everything times 3. When I do that, I have to make sure I multiply all 3 parts by 3. All 3 parts have to be multiplied. So 3 times negative 3 is negative 9, is less than, those cancel out, so 2x plus 5 is less than 15. All right, here's where this becomes a little different. When I subtract my 5, because my goal is to keep the x in the middle. When I subtract my 5, I have to do it from both of the inequality sides. Negative 9 minus 5 is negative 14, is less than 2x. That cancels. Is less than or equal to 15 minus 5 is 10. Now I'm going to divide by 2, but I have to do all 3 parts. Notice whatever I do to 1, I have to do to all 3 parts. So negative 14 divided by 2 is negative 7, is less than x, is less than or equal to 5. Now let's talk about how to graph this, and then how to write our solution set. So I know I've got negative 7 here. All right, and I'm just going to my number line is not right, but that's okay. I'm just doing it for you to see. All right, so I'm looking at x is less than or equal to, so close dot because it's equal to, so it has to be everything less than or equal to 5. Then I'm going to look at this part. X is greater than negative 7. So open circle everything above negative 7. So in order to write this, I need to look at everything that they have in common. So my solution set's going to be everything that they have in the middle in common. Now, let's think about this. I'm starting at negative 7, but negative 7 is not included. And this time I'm not going to infinity. I'm stopping at 5, but 5 is included. So my solution set would look like this. Okay? Guys, if you have questions, all you have to do is ask.